Let's go ahead and find the inverses algebraically of these functions. Here I have f of x equals 2x minus 11. If I wanted to find the inverse, the first thing I do is I exchange a y for the f of x. Then displace the y and the x and exchange places. Now solve for y. So the goal is to get y all by itself. So if I wanted to get y all by itself, I could add 11 and divide by 2. Now, once I have solved for y, I want to exchange the y for the function f of negative 1. So I'm going to replace the y with its name, which is the inverse of the function. Now always check your answers. Over here we have to do 2 checks. The first check we're going to do is we're going to take f inverse of f of x. And the second check we will do is take f of the inverse. Both of these have to be equal to x. So first we're going to take the original function, which was right here, and we're going to plug it into the inverse, which is right here. So this x is actually going to be 2x minus 11 plus 11 over 2. 2x minus 11 plus 11, well, that's just 2x, and 2x over 2 is x. So that checks. Over here we take the inverse and plug it into the function. So we're going to take all of this and plug it in for x over here. You're going to see the 2's will cancel, and we're left with x plus 11 minus 11, which is x. So this is indeed the inverse. Again, if you wanted to graph these, you could graph them on the same set of axes, and you'll see that they will be inverses of each other. Let me show you what the graph of these would look like. So let's plot first 2x minus 11. Let's also plot x plus 11 divided by 2. And then lastly, I'm also going to graph y equals x, which is the line of symmetry. So when I graph all of those on the same set of axes, here's the function, here's the inverse, and now here's the line of symmetry. Let me zoom out just a little bit. There's the function, there's the inverse, there's the line of symmetry. Let's try another one. First, replace f of x with y. Then replace y with x. Now solve for y. Here what I'm going to do, I think, is I'm going to get rid of the denominator. So I'm going to multiply everything in both sides of the equation. I'm going to multiply everything by y. I think that's going to help me get rid of the y from the denominator. So that becomes y times x equals 4 plus 9y. Let me move all the y's to one side. Factor out the y. And then divide by x minus 9. There's probably other easier ways to do that than the way I did. That was just the way I chose to do that problem. So the last thing you do is replace this y with its name, which is the inverse. Of course, we want to check this. We're not positive this is the inverse until we've checked both sides, but that's what we're going to do next. So let's go ahead over here and do both checks. The first check we will do is we will take f and plug it into the inverse. So let's take this f and plug it into the inverse x right here. So in the denominator, you have plus 9 minus 9, so those will go away. So I have 4 divided by 4 over x. Well, this is equivalent to, if we take the denominator and we flip it upside down, 4 times x over 4, which is x. Same for the other direction. Let's take the inverse and plug it into the original function. So we're going to take this inverse and plug, we're going to take this inverse and we're going to plug that into the original function here. So this becomes 4 over x, but we're going to use this, plus 9. So here we have 4 divided by 4, so this just becomes x minus 9 plus 9, which is x. So this does check out, which means this is our inverse. Let's check it graphically to show you that it is the same. Alright, so the first one we have is 4 over x plus 9. The next one is the inverse, which is 4 divided by x minus 9. And then we have the symmetrical line lasted third. So the first graph will be the function, then its inverse, and then the line of symmetry. Let's zoom that out a little bit. Let's try that one more time. So here's the function, here's the inverse, and then there's the line of symmetry. So you can see that these two sides are symmetric of each other over the symmetrical line. Good. All right, let's try 2 more. Here we've got a function which is 1 minus 3x. So the first thing we do is we plug y in for f of x. Then we swap the y in the x. Then we solve for y. So let's subtract 1 and divide by negative 3. So the inverse is equal to x minus 1 over negative 3. So if I wanted to check that, I will do so over here. In the first check, we'll take the inverse and plug it into the function. So we're going to use the function 1 minus 3x, but instead for x, we're going to use the inverse. So you're going to see that these negative 3's are going to cancel. So I have 1 plus x minus 1, which is x. So that does check out. Now we're going to take the function and we'll plug it into the inverse. So this is x minus 1, but we're going to use this for x. Well, we got 1 minus 1, so those cancel out. So we have negative 3x over negative 3. So you see the negative 3's will going to cancel, and we're left with x. So this is the inverse. Let's try one more. Again, change f of x out for y. Then switch the x's and the y's. The domain becomes the range, and the range becomes a domain. Now solve for y. So I'm going to multiply both sides by 3 plus y. So this becomes x times 3 plus y equals 2. Distribute. subtract the 3x, and divide by x. So my inverse is equal to 2 minus 3x over x. And this does check out. If I wanted to check this, the first time I take the inverse and I will plug it in for x over here. I am running out of a little room here, so I'll do it over here on a separate piece of paper. Okay? So if I wanted to check out this, first thing I do is I take the inverse and I plug it into the original function. So this becomes 2 over 3 plus x, but I'm going to use this for x. So this becomes 2 over 3 x over x, because I want to get common denominators. So I'm multiplying this by x over x, plus 2 minus 3x over x. So then I can combine all of that together, which becomes 2 over 3x plus 2 minus 3x over x. And you'll see that these 3x's will cancel. So then I have 2 divided by 2 over x. Well, when you divide by a fraction, you can use the reciprocal of the denominator and multiply. So it becomes 2 times x over 2, which is x. So that side checks. Let's also check to see if it works the other way. The other direction, now we're going to take the original function and plug it into the inverse. So the inverse is 2 minus 3x, but instead of x, we're going to use this function here, which is 2 over 3 plus x. And that's divided by x, which again is 2 over 3 plus x. All right, let's start by distributing up top here. So this gives me 2 minus 6 over 3 plus x over 2 over 3 plus x. Then we're going to get a common denominator. So this is going to need a 3 plus x and a 3 plus x so that I can add these two things together. So this becomes 6 plus 2x over 3 plus x minus 6 over 3 plus x over 2 over 3 plus x. Putting all this together becomes 6 plus 2x minus 6 over 3 plus x over 2 over 3 plus x. You'll see the 6's will cancel, and this becomes 2x over 3 plus x times the reciprocal of the denominator, which is 3 plus x over 2. 2x over 2 is x. So that does check out as well. For the last problem, it asks us to find the inverse of the following domain restricted function. So I have a domain restriction saying that x in the domain has to be greater than or equal to 0. And then state the domain in the range of both functions. So we've got a function here that f of x is equal to x squared minus 2, but x has to be greater than or equal to 0. So the first thing we're going to do is we're going to find the inverse first. So first step is to substitute y in for f of x. Then swap the y with the x. And solve for y if possible. So let's add 2. And then we're going to have to take the square root of both sides. So my inverse is going to be equal to plus or minus the square root of x plus 2. So this is my inverse that I found. But we're only going to keep the positive version because we only want the x's that are greater than or equal to 0. So if we look at the domain and the range, of the original function, the domain says that x is greater than or equal to 0. That was given to me. The range is the f of x, which is only going to be greater than or equal to -2. Because when you look at the y value, there is no way I can ever get something less than -2, because when you square this value, the smallest it could ever be is 0. No matter what x you plug in there, the smallest it will ever be is 0, because when you square it, you get positive. So when you minus 2, the smallest value I'll ever get for y is going to be -2. It can never be anything smaller than that. Now when we look at the inverse, the domain of the original function becomes the range of the inverse, and the range of the original function becomes the domain of the inverse. So since my range, my y, had to be greater than -2 for my function, that means x has to be greater than or equal to -2 for my inverse. Since x had to be greater than or equal to 0 for the function, that means y has to be greater than or equal to 0 for my inverse.